All right, so what we're going to be doing is looking at a few of these problems from the exponential models test. I'm not going to do this problem because this is a little bit easy. Would you guys agree this is the easy one? Okay, so if it dies by 30%, what's happening? We're taking what, 100%, and what are we taking away? 30%, but I'm not going to tell you what percentage that is. All right, okay, so we're not going to do that one. But I'm going to go over here. When it says, what's the decay factor? Does everybody understand what the decay factor is? Or not sure? So let's say, for example, let's say you bought a really nice car. Let's say it was 40,000. All right, $40,000. You're like, woo! All right, and then all of a sudden they let you know it's going to depreciate. But let's say they don't. It's not 8%. Let's say it's, I don't know, 12%. All right. If it depreciates at 12%, next, like per year, what's it going to go down? It's going to go down to what? What do we have left? 88 what? 88%, right? So we're at 8. So what does it keep? It keeps 88% of whatever the value is. So what would be the decay factor if it depreciated at 12%? The decay factor would be 0.88. That's what it would be. That would be the decay factor. I'm not going to tell you the answer to number 2 though. Okay. This one, it deals with increasing by what? Increasing by 9%, so that's a pretty easy one. Does anybody want me to see how this would work? Like the formula that you would have to use if we have a fish population and it's at 8,000. All right, let's say it decreases by, give me another percentage besides 6. 27%? Okay, it's so 20, if it decreases by 27%, what we have to do is we have to do 100% minus 27%. So what would be our decay factor? What do you got? 73, right? So we have 73%, so we put point, so it keeps 73%, and then it says after 10 years. So if it does it per year, then what number I'm going to put up here? I'm going to put a 10. And so if this was my problem, if I start out with 8,000 and it depreciated, or sorry, reduced by 27%, then we keep 73%, and then we raise it to the power of 10, and there would be approximately 344 fish left after 10 years. Okay? So remember, what you have to think about is when you're doing these problems, if it decreases by this percent, what does it end up keeping? It still keeps what? 94% of the fish per year. So you'd have to put a different number in there for 0.73. I'm not going to tell you the decimal though. All right, let's move on to the next one. That one's pretty easy. That one was pretty easy. Okay, on this one, it says choose all answers that apply. Okay, so there might be more than one answer. Hint, hint. Okay, James and Giant Peach. Mosquitoes. Let me show you guys how to set this one up. Was this one that was difficulty or not difficult? Easy? Okay. All right. How about this? Yeah. All right, so here we go. On the first day of winter, an entire field of trees started losing its flowers. Okay? The number of locusts remaining alive in this population decreases rapidly due to the lack of flowers for them to eat, blah, 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 blah. T is days, so I'm going to write, ready? T equals days. And I'm going to create a new function right over here, ready? Let's say we start with a population of locusts that's 10,000. So we're going to start with 10,000 instead of 8,950. And let's say my decay factor right here, let's call it 0.5. But instead of 2t, I'm going to put 4t. So I'm going to do a very similar problem. I'm going to actually answer the exact same question, just with different numbers. So if you want to write this down, I'm going to answer the exact same question, except with different numbers. Now, if it says removed daily, now this is not removed daily. Like what number would have to go there for it to actually be removed 50%? 1/4. Okay? So in a quarter of a day, because 1/4 times a 4 is 1. So in a quarter of a day, what's removed? 50%. But what's it removed daily? Like what percentage is removed daily? So here's what we got to do. We got to take 0.4, sorry, not 0.4, 0.5, and we got to raise that sucker to the power of 4 and press enter. Now what happens there? We get 0.0625. So you do 1 minus whatever you get. Holy cow. So what percentage would be removed in this particular case? If we had 100%, right? And we're removing 6.25%, or it's multiplying by 6.25%. What's actually being removed in this particular case? 93.75%. Yeah, yours isn't going to be that hard, okay? Yours isn't going to be hard. So what is that? Basically, what do you guys have to do? You have to take whatever this is, square it, and whatever you get, you got to make sure you know what's being removed. All right, so what did this basically become? What did 0.5 raised to the power of 4 become? It was what? 0.0625, but that means we'd actually have to remove 93.75% of the population. So this is a ridiculous removal. All right? Yes, me too. Who wants locusts, right? They're just a pest. Oh, okay. All right. Okay, so that one, you have to do what? You got to make sure you do what? Do this raised to that power. It's going to get a decimal, and you got to make sure you know what percentage is being removed. Okay, do you guys see this one right here? It says what is the what? Decay factor. So let's say I use the exact same example. Ready? 0.5 to the power of 4t. Well, what would be our decay factor? 0.0625 to the power of 1t if we do 0.5 to the power of 4. So this answer, if I just changed this to this would be my answer. Now yours answer is going to be a heck of a lot easier. All right. So let's move on to the next one. What percentage is being removed in half of a day? So let's just use the exact same model. Ready? 0.5 parentheses to the power of 4t. So if we wanted to remove something in half of a day, what number would I have to plug in for my t? Nope. What number am I plugging in? A half. So watch this. I do 0.5. I do 4 times what number? 1/2, which becomes what? 0.5 squared. 0.5 times 0.5 is 0.25. So what percentage, if this was right here, if I multiply this out, what percentage does it keep? It keeps 25%, but what percentage is being removed? 75%. So I'm doing the same process, guys. I'm just changing it from what? From a 0.7 raised to the power of 2 to what? 0.5 raised to the power of 4. So I'm not just giving you guys the answer. Okay? So if this is the decay factor, if that's the decay factor, that's the percentage that's being removed. Because that's what it's keeping, and that's what's being extinguished or decaying or being removed. Okay? This is pretty easy. I'm not going to tell you the initial size. Okay. So let's just right now for number 14, let's just make up a new problem. Here's our new function. I'm starting out with 500 instead of 300, and I'm doing 1.45 to the power of t. All right? Now, what does t represent in this problem? T equals time, which is days. But we're going from days to what? To weeks. So all I got to do to make it go from days to weeks, to figure out that, I got to put a 7 right there. Now in the calculator, what I'd have to do is I'd have to do 1.45 raised to the power of 7 and press enter. And I got what? 13.476. 13.476. 13.476. 13.4. Did I say it right? Yeah, 76. If I had to round it to 2 decimals, what would I do for mine? I'd put 13.48, and that's what I would type in for my answer. So if I'm going from days to weeks, all I got to do is change it from a t to the power of 7t. And then you just use your calculator and round correctly. Okay. I'm not going to tell you this one because this is pretty much like self-explanatory. All right. It's, by the way, here's the one thing I'm going to ask you guys. Ready? If it loses 10% of its mass, what does it keep? If it loses 10%, what percent does it keep? It keeps 90%. So just remember, the 90% is going to represent your decay factor. Okay? All right, so we have a model. Okay? And I'm going to change it from losing 10%, ready, to losing 20%. So I'm going to say it's an element that loses 20%. And I'm changing it from 871, I'm changing it to 750 for your example. And I'm changing the initial amount from 960 to 1,000. So if I was going to write this problem, I would say m of t equals 1,000. And if it loses 20%, that means it keeps 80%. And if it loses it every 750 years, that means it's t over 750. But if I wanted to figure out what it does on a daily dadgum basis, holy cow. A daily basis, that means it's going to be 0.80 raised to the power of 1 over 750. So I'd have to put 0.8 or 0.80 raised to the power of 1 over 750, and that would give me my answer. And I'm going to do it to 4 decimal places. So I'm going to do 0.8 raised to the power of 1 over 750. I got 0.9997. So what does that mean? That right there is my every single. Oh, yeah, it's a yearly basis, not daily basis. I know. Hold on. I said daily. You know what, guys? I'm gonna edit it. I meant to put yearly, not daily. I apologize. So I will go back and edit that. That's supposed to be yearly. When I was thinking of the answer, I was thinking of yearly, but I typed in daily. Okay? So just make sure on this problem, make it yearly, not daily. So every single year, that's what you're going to be doing. My apologies on that. Okay? All right. Let's see here. All right. So here's the problem that I would like you guys to do with me. Okay? We have our model, n of t, equals, it starts with what? 960. It's losing 10% of its mass, which means it keeps this. It's over 871 years. Bless you. Now, if we want to lose half of its mass, what does this number have to be? If it loses half of it, it's got to get down to what? 480. All right? So it's got to get to 480. That's what we're doing. Now, if we divided both sides, ready, by 960, this becomes what? Half. And this is raised to the power of t over 871. So we're trying to figure out, right now, we're trying to figure out when does this equal what? 1/2. So here's what I'd like you guys to do. Now, I have not taught you logarithms, so I'm not going to do it the logarithm way, okay? But what was our original function? I'm just going to put f of x. It was equal to what? 960 parentheses 0.9, right? Or 0.9, 0.90, whatever. All right, raised to the power of, okay. Then we got to do another fraction, right? Okay, so hold on, I got to do another fraction. There we go. So I'm going to put x over 871. Okay, so we have that. But watch this. I'm going to put y equals. We want y equal to what? 480, because we want our new y value to be 480. Now, here's the cool thing. Watch this. Do you guys see how you see a graph and you see a line? I'm not going to tell you where the answer is, but wherever these two babies meet, just round it to the nearest whole year, and that'll be your answer. So I'm not going to give it to you, but I basically did. Okay? Now, the reason I did this problem is because I want you guys to understand we're going to deal logarithms next unit. Well, not next unit, but the next thing we're talking about is logarithms. That's how you solve exponential problems. Okay? So that's how you would do it. All right? Let's see here. This one there's really not a whole bunch right here. What does that say? Tn days, and it's asking for the what? Every day, what factor does it grow, correct? So do I have to change anything? No. This one's pretty self-explanatory. By the way, I will do a quick little fraction problem. If you have 100% and you're dealing with thirds, that means you have what? 3/3. If you gain 2/3, right? If you're gaining 2/3, what would be your new fraction? 5/3. That's why the fraction's 5/3. But it doesn't gain 5/3 every single day. There's a certain amount of days that it would take before it gains 2/3, or it's multiplied by a factor of 5/3. So there's a little hint on that one. Now, what's the daily growth? What would we have to do? For the daily growth, we'd have to take this factor and multiply it by a certain fraction. I'm not going to tell you what fraction. You have to do this factor by that fraction. But I will do a quick little example. This will be the last example. Then I'll let you guys go back and take the test again. So give me a new starting amount. What's my new initial amount? I don't care what it is. 800. Okay. What is my new improper fraction besides 5/3? How about 7/2? Okay? And if I put t over not 5.9, let's say I put 7.8. And I wanted to do the daily growth. I would do 7/2, all right? And I would raise that to a power of 1/7.8. And that's what I would do. So I would do 7 divided by 2, and I would raise it to the power of 1 divided by 7.8. If it took 7.8 days to do it, then my answer would be 1.17. 1.17. Okay? So here's what I want you guys to do. I'm going to go ahead and pause this and put that up on YouTube. No, I'll leave it up there for a second.